Hello, this is Sadbir. The topic of our discussion in this video is the derivative of polynomial and exponential function. Here I have four basic rules which we need to calculate the derivative of any polynomial. Our first rule is the derivative of a constant is zero. And second rule says that if the constant is multiplying to a function, then the constant can be pulled out from the derivative notation. And the third rule is sum and differences rule, which says that the derivative of the sum of the differences of two functions is the sum and difference of their derivative. And the fourth rule is a very powerful rule, which is called a power rule. If you have a power function x to the power n, then the derivative of that function is you drop the power and you take 1 from the power. So these are the four basic rules which we need to calculate the derivative of any polynomial function. Let's use these rules on some few simple example. So here I have 5 functions, and we will use these rules to calculate the derivative of them. So the first function I can see this is a constant function because there is no x involved in this function. And pi is a number which is a 3.14 approximate number 3.14. So derivative of this function is just 0 because it's a constant, so we will use the constant rule here. The derivative of x, if we calculate the derivative of x, you will use the power rule. You drop, because x has a 1 power, so you will use that rule. So you drop the power and you take 1 from the power. Therefore, this will become 1 times x to the power 0. And we know that if you have a 0 to any number, then it's just simply 1. So the derivative of x is 1. Here we again use the power rule. The derivative of that function will be 2/3, and we will take 2/3 minus 1. So if I simplify this one, this will be 2/3 x to the power minus 1/3. So this is how we will calculate the derivative of a polynomial, even though the exponent is a fraction. Here we have a quotient, so we will simplify this one first so that we can use the power rule. So now our function is a 2x to the power negative 3. So I can use the power rule and also the constant multiple rule. It says that the constant will stay outside, and the derivative of this be using the power rule is power will drop and we will take 1 from the power. So if I simplify, this is a 6x to the power negative 4. And here also I will use the constant multiplication and the power rule, and would say the constant will multiply to the power and we will take 1 from the power. So this is a 35x to the power 4. So these are a few examples of calculating the derivative using the constant rule, constant multiple rule, and power rules. Now we will use the sum and differences rules and calculate the derivative of polynomials in the next example. So here I have a polynomial function x to the power 7 minus 12 x to the power 4 plus x square minus x minus 3. I will calculate the derivative of using the previous four basic rule of the differentiation. So let's begin this problem. So this is a function, polynomial function, which is the addition and subtraction of these 5 power functions and some constant function. So the sum and difference rule says that the derivative of each term we can calculate separately. So dy by dx of 12x to the power 4 plus dy by dx of x square minus dy by dx of x and minus dy by dx of 3. This is my this sum and differences rule, where you can basically, if the two functions are added, their derivative will be addition of these two functions or the subtraction. And now here in this function x to the power 7, which is a power function, I will use the power rule. Here, this is a constant multiplied to the function. I can pull out the constant from the notation of the derivative, x to the power 4. And here I will use the power rule because x to the power 2 is a power function. So 2x to the power 2 minus 1. And we already know in the last example that derivative of x is 1. And here I will use the derivative of a constant is 0. So let's simplify. This is x to the power now 6. And this is a 12. And here again, this is a power function. So it's going to be a 4x to the power 4 minus 1, which is a 3. And this is a 2 minus 1 x to the power 1 minus 1. Therefore, this one is now equal to 7x to the power 6 minus 48x to the power 3 plus 2x minus 1. So this is your final answer. So I will box that answer. Let's do one more example. Here I have this polynomial, which is the sum of these 5 terms, which are added and subtracted together from each other. So I will use the sum and differences rule first. So the derivative of this polynomial will be dy by df of square root of x, means x to the power 1/2, minus dy by dx of 12x to the power 7/2 plus dy by dx of x square minus dy by dx of x and minus dy by dx of pi square. So here x to the power 1/2, I will drop the power and take 1 from the power to calculate the derivative of this function. So this is a power rule. The derivative next term is 12 times the derivative of this power function, which is a 7/2 x to the power 7/2 minus 1. So when the constant is multiplying to the function, you just basically don't take the derivative of the constant. You multiply the derivative of the function to that constant. So here is x square. So you drop the power and you take 1 from the power. Derivative of x is 1. And here is a pi. So don't get confused that pi square is a power function. It is not. It's just a constant because there is no x in it. So derivative of this function will be simply 0 by using the constant rule. So this is a 1/2 x to the power 1/2 minus 1/2 is a 1/2, and this is a 6. This cancel to 6, and 6 times 7 is 42. So x to the power 7/2 minus 1 is 5/2 plus 2x to the power 1 minus 1. So this is the derivative of that function. So I will box my answer. So here I have one quiz problems where you can practice your skill of derivatives on this question. I have another quiz problem, so where you have to calculate the derivative of the function, which is also the velocity of the function, and calculate the derivative at a value t is equal to 2, and then verify which one is the right answer. So you can leave your answer in the comment section below, so that if you want to compare with other people. Next topic is that how to calculate the derivative of the exponential function. So derivative of the exponential initially is given by this formula, which says that if you have exponential function x to the power b, it is a derivative is x natural log of b. For example, if we calculate the derivative dy by dx of 3 to the power x, then the derivative is simply 3 to the power x times natural log of e. So the derivative of the exponential function is the exponential function, original exponential function times the derivative of the base. So similarly, you can calculate the derivative of e to the power x by using this formula. It will be e to the power x, original function, times the natural log of base. And we know that the natural log of e is 1, so derivative of e to the power x is e to the power x. So let's practice this rule on a few more examples. So I have this examples where we will use all the 5 rules, the 4 basic rule of differentiation and plus exponential differentiation. So the derivative f prime of x will be dy by dx of square root of 30 plus dy by dx of 30 to the power x plus dy by dx of 7e to the power x. This is the constant rule, derivative of constant, because 30 raised to power 1/2 is a constant because there is no x in it. So derivative of this is 0. Here is, you can see this is the rule exponential function 30 to the power x, and derivative of this function is original function time the natural log of 30. And here 7 times e to the power x, 7 stay outside of the differentiation, and derivative of e to the power x is e to the power x. So if I write down this one, this will be 30 to the power x natural log of 30, and that is a 7e to the power x. That's your final answer for this problem. Our next problem is x to the 1 over square root of x plus 5e to the power x. Before I calculate the derivative of this function, I will simplify this function and make that function turn into a power function. So this is x to the power 1/2 plus 5e to the power x, and which will become x to the power negative 1/2 plus 5e to the power x. So if I calculate the derivative of this function by using the first sum rule, so dy by dx of x to the power negative 1/2 plus dy by dx of 5e to the power x. So here I will use the power rule. So I will drop the power 1/2 and take 1 from the power. And here I will use the constant multiplied to the derivative of the function dy by dx of e to the power x. So you can pull out the constant from the notation of the derivative. So this is a negative 1/2, and this is x to the power negative 1/2 minus 1 is a minus 3/2, and this is a 5. We know that derivative of e is a e to the power x is e to the power x. So that is our final answer for that problem. Let's take one more problem. This is a problem number 3. Again, I will simplify. This problem can be written as square root of 2u and plus the square root of 3 and the square root of u. Because we have this property a, b, square root of the product is the product of the square root. So if I calculate the derivative of this function, I will use first sum rule dy by du, because u is the variable here, and therefore square root of 2u plus d over du of square root of 3 in u to the power 1/2. I can pull out the constant out of the derivative, so it will be d over du u, and this is the square root of 3d over du u to the power 1/2. Here I will use the power rule, here I will use the power rule, so this will be square root of 2. So u to the power 1 if I drop 1 and take 1 from the power, u to the power 0 is simply 1. So plus this is the square root of 3. I will drop 1/2 and take 1 from that. So this will be 2 square root of u to the power 0 is 1. So that's the square root of 2. Just this is the square root of 3 divided by 2, u to the power -1/2. That's complete the solution of that problem. Let's take one more problem. This is the problem number 4. And the derivative of this function will be simply f prime of x will be dy by dx of 3 to the power 5 minus dy by dx of 2x to the power 3 plus dy by dx of 50x plus dy by dx of e to the power x. So this will be 3 times 5 times x to the power 4. This will be 2 times 3 times x to the power 2. To take 1 from the power. And this is the 50 times derivative of x, which is a 1, and derivative of e to the power. If you simplify, this is a 15x to the power 4. This is a 6x square plus 50 times 1 is 50 plus e to the power x. We have 2 more problems, 2 more examples. So this one is, again, I have to simplify. This is a x times x to the power 1/2 plus 2 e to the power x. We know that when we have base is same, the power will add. So 1 plus 1/2 plus 2 e to the power x. So the function is x to the power 3/2 plus 2 e to the power x. So now we calculate the derivative. So f prime of x is 3/2. You drop the power, you take 1 from the power, you add 2 times derivative of e to the power x is e to the power x. So this is a 3/2 x to the power 1/2. 3/2 minus 1 is 1/2 plus e to the power x. Our last problem is here. So this is, again, if I simplify, this is x to the power 1/2 plus 3 to the power x plus e to the power x. So derivative of that function is 1/2 x to the power 1/2 minus 1. Derivative of the exponential function is exponential function as it is time the natural log of the base, and the derivative of e to the power x is equal. So this will be 1/2 x to the power -1/2 plus 3 to the power x natural log of 3 plus e to the power. So here are the derivative of all these 6 functions. Here I have the quiz number 3 for you to practice on these rules which you will learn in this video. And here is another example where we will use the derivative of e to the power x. We use this rule to calculate the equation of the tangent line. Let's start that problem. So to find the tangent line, you need to find first the point. So the 2 things we need to find: what is the point, at which point this tangent line pass, and what is the slope. And then we will find the equation of tangent line, which will be basically y is equal to mx plus b, where a, m, and b we will determine. So point is given, the x value is a given. We need to calculate the y value. So to calculate the y value of the point, you just simply plug the point into the function. So what is our function? Function is a 2 e to the power x. If I plug 1 on the top, e to the power x is just to become e to the power 1, which is just e. Calculate the slope. In order to calculate the slope, we need to find the derivative of the function. So this function is a 2 e to the power x. So derivative is the 2 times dy by dx of e to the power x, which is a 2 e to the power x, because we know derivative of e to the power x is e to the power x. So the slope of this tangent line will be when you plug the x value into the derivative. So if I plug 2 to the power e to the power 1, it will be 2. So now I will plug the m and the point into the equation of the line to calculate m and b. So first, if I plug the m, it will be 2e x plus b. Since this line, this line passes through 1, 2e, so it means 2e is a y value, and when you plug the x value, that will be equal to y value. So from here, I can simplify and I will see that I will get my equal to 0. So if I plug this b is equal to 0 here in the equation of the line, so the equation of the line will be simply 2ex. So that's our final answer. So this is all I have in this video. If you like this video, please subscribe my channel and hit the bell button so you can get my next video. In the next